right, so now let's look in detail to our f prime of x, and we're going to actually just do an example. So let's do find a point of inflection, and I'll give you a function of our f of x is equal to cosine x, and we'll do it on 0 to 2 pi. Okay, so a point of inflection, just to refresh, is basically where does our second derivative, so f double prime, change signs. All right, so that's what we really want, change signs. Okay, so let's find our second derivative first of all. So we have to take the first derivative first, so we have a negative sine x, and then f double prime of x is then negative cosine x. Okay, so what we have to do first is see where f double prime of x, so where this guy, where it's equal to 0, because it does have to pass through 0, or be undefined. Is that a thing? Anyways, I believe usually the second derivative has to equal 0 for it to change signs, right? So anyways, cosine x, negative cosine x is equal to 0 when cosine x is equal to 0, and that is when our x is equal to pi over 2, so right at the top or right at the bottom. So we'll put 3 pi over 2, and we're only doing on one period, right? So 0 to 2 pi. So that's as far as we go. So we could have points of inflection. These are possible points of inflection, but we don't know for sure if the second derivative changes signs or not there. So let's check. So what we're going to do is a sign analysis on the next slide. So we found, and these can be called critical points for our f double prime of x. Okay, so we have this one and this one here. And we know that f double prime of x was equal to negative cosine x. So what we're going to do is a sign analysis for the second derivative. So sign analysis for second derivative. Okay, so second derivative. So what we're going to do is draw our number line. Okay, and then we're going to plant them on the line, the critical points here. So we have pi over 2 and 3 pi over 2. Okay, and then we do, instead of having that negative infinity over here and the positive infinity over there, because we were given a certain interval, we have to respect that interval. So our interval was 0 to 2 pi, so we're going to stay within that zone. So we're not going all the way to infinity in either direction. Okay, so anyway, so now what we're going to do is find those easy test points. So in here, I'm going to pick pi over 4. In between here, I'm just going to pick pi. And then over here, I'll pick 7 pi over 4. Okay, so these are our test points. We have 3 of them because we have 3 little intervals in there. And what we're going to do is basically just plug those into our second derivative, because that's what we're analyzing, right? Our second derivative here. Okay, so f double prime of pi over 4 is going to equal negative cosine pi over 4, which is going to turn out to be a negative answer, right? So we get a negative on top of that pi over 4. Now if we plug in a pi, we get f double prime of pi is equal to negative cosine pi, and that would be a negative 1, so that's going to turn out to be a positive number. Okay, so we have a positive right over that pi. And then our last one's 7 pi over 4, so let's plug that one in. We get negative cosine 7 pi over 4, and 7 pi over 4 is on the right-hand side of the y-axis, so that means that we're going to have a negative positive number, so that will also turn out to be a negative number. Okay, so we have a negative right above that 7 pi over 4. Okay, so now let's see what's going on here. We have our timeline here, or our number line. I'll redraw it on the next slide in a more simple, less crowded fashion. So what we have is f double prime. This is our number line, which I should make more horizontal. There we go. So we have our endpoints, which are 0 to 2 pi. We tried out 7 pi over 4, a pi, and a pi over 4. And our critical points were pi over 2 and 3 pi over 2. And we got let's see, we had a negative first, and then a positive in the middle, and then we went back to negative. Okay, so this is for the second derivative. So that means we were looking to see at what points does our f double prime change signs, okay? So from here, from this interval to this interval, when we cross over there, that means that we do change signs because we switch from negative to positive. So this is a point of inflection. Now let's look at the next one. We switch from positive to negative. So this also is a point of inflection. Okay? So that's basically it. That's all we have to do is say that there are points of inflection at, and then we just list x equals pi over 2, that's a 2, and x equals 3 pi over 2. Okay? So that's basically it for that problem.